Okay. Okay, so last time we dealt with utility theory, and I provided this example of application where basically example of application that you certainly remember, which is also described with full details in the slides which I am projecting now. And basically from this example we learned how to incorporate our propensity or aversion to take risks during the decision-making process. And I told you that this approach is particularly useful when we want to adopt a transparent decision-making process, because it allows for comparing different views, again, on the opportunity or not to take a certain risk. So what are then the pros, the advantages of this kind of approach, of the use of utility theory in order to carry out this incorporation of our propensity or aversion to risk? The pros is that the decision is more objective. Besides then the opportunity of taking into account our propensity to risk, the decision is objective and it's very transparent, as I said. There are some drawbacks. First of all, defining the utility function is problematic. I basically skipped this step because, as you may remember, I proposed a utility function which I defined just by chance, by only taking care that the fundamental axioms are respected, namely that the utility of the minimum benefit is 0, the utility of the maximum is 1, and the function is not decreasing. And, but I didn't incorporate really in the definition in the example that I proposed to you considerations on the opportunity or not to take risks. And actually the definition of the utility function is not easy, and usually it is defined through a consultation process among the stakeholders. This is needed. If you really want to pursue objectivity, you need, when defining the utility function, to make a mix of the necessarily different opinions of the stakeholders. And this process can be a bit complicated. Keep in mind that for important decision-making processes, the stakeholders may be politicians, may be speaking different languages, and therefore it's not easy to sit around the table and to agree on an opinion about the opportunity or not to take a risk, because of course depending on the nature of the stakeholder, on their behavior, they have different opinions. And then there is also one thing that we should take into account. It's extremely difficult to evaluate the opportunity to run the risk of getting trapped into a very exceptional event. I mean, it's easy for you to evaluate the risk associated to activities that you carry out in your everyday life. But it's difficult for you to evaluate what's the risk if you experience an extreme situation. Like for instance, if you were given a Ferrari to try and you want to evaluate what is the risk of running at 300 kilometers per hour, it's difficult for you to evaluate the risk. Why you are used to evaluate the risk of running at 100 kilometers per hour in the center of the city, because sometimes we do that, or we did that in our youth. Indeed, if you have to evaluate a very extreme situation, this is not easy. And this is why people that do like extreme sporting activities, they need to be trained, because when you experience extreme situations, you need to be guided in this, because otherwise it's difficult for you to understand what is the associated risk. In our case, for instance, if you were told that you run the risk of experiencing a drought with a return period of 1,000 years, return period means that such event happens on average every 1,000 years, we have no clue of what it means. So basically it's difficult for us to establish whether or not we are willing to run such a risk. And therefore, if one asks us, if one suggests us a design for a water supply system, and the guy says, look, this design is fine, but it may cover against droughts up to a return period of 500 years, it's difficult for you to say that's fine or not. If they say that you experience a bad situation every 10 years, then you can understand what it may mean, because it's an experience that you probably already had in your life. If it is an event that occurs on average every 1,000 years, for you it's difficult to understand what it means. So it's difficult to say if you are willing to run such a risk. On one end you may say, it's very unlikely that happens to me, so you may accept the risk. And on the other hand, you might be very concerned by the consequences, because it's something that you can't really predict. So this is something that we have to take into account. That is to say that in water resources management, usually we don't design against very extreme events. We do that when we design flood protection works, when we design roads, because or when we design, for instance, in another discipline, planes, because we really want to make sure that nothing happens. But for instance, when you design sewer systems, I want to give an example that is easily understandable, you don't need to get protected against an event that happens every 100 years. Usually you design the sewer systems against a return period of from 2 to 10 years, because every 10 years you may accept that the sewer system fails. So this is not a big problem. And even in the case of water resources management, usually, if your water supply system fails, this is, in many of the situations, not really a big damage. Of course, it's a damage, but not a damage that involves the death of 1,000 people. Instead, when you design against flood, to protect people against floods, or you design a dam, then really, if you fail, you may kill a couple of thousand people, like it happened for the Bayonne Dam. So this is something that helps us, but still you have to be very careful when somebody asks you to take a decision with respect to an event that is very extreme. You have to be very careful and to realize that you may have not the sufficient information that allows you to make an informed decision and a wise decision. And then you need, once again, I want to say that when you have to compare different opinions and you are about the mediating in the process, you have to use what in Italian we call the good sense, buon senso, we say in Italian, which means a very wise approach. You have to try to understand what is the behavior of the people that you are dealing with. Try to understand who is wise, who is trying to exaggerate in defining the needs, defining the information for the problem. Because if it is relatively easy to provide an analytical interpretation for a decision process, it is extremely difficult to provide an analytical interpretation for a compromise, to reach a compromise. We have, of course, some tools, some approaches that may help us, but at the end of the story, when you try to reach a mediation or compromise, you have to be able of interpreting the behavior of the person and try to go beyond the words that that person says. It's extremely important, your capability of reaching a wise comprehension of the setting, of the context. I want to say that because your behavior, the way in which you approach the problem, is the key to success in the context of transparent and open decision making. If you really want to be transparent and to involve a lot of stakeholders, you have to be very aware that besides knowing the technical details of the problem and the technical details of the possible solutions, you have to be very talented in understanding the behavior of people, and your attitude is what makes the difference. Meaning that if you lose the control, for instance, you instantaneously lose your credibility and then you're lost. So your approach must always be very wise, and you should keep in mind that if you realize that there is a best solution, you don't have to impose it. You have to convince people that this is the best solution. It makes a big difference. And I would say that this is a typical behavior of leadership. In these processes, if you are the mediator, you are the leader. And leadership means that you don't decide according to your individual judgment. Leadership means that you convince people that your individual judgment is the better for them. This is the difference between a successful mediation, a successful, in this case, leadership, and the difference with respect to a mediation that is not very successful. And in this case, as I said, it is extremely important, your wise approach. And this is something that is difficult to teach, but to some extent it can be taught, because it's in the end, it's not difficult. I mean, if one says you don't have to lose the control, of course, it's not difficult. On the other hand, there are situations where maybe because the people are not fully aware, they lose the control even if it's not needed. And this, in water resources management, is something that you really have to avoid. It's not like civil protection, where you don't have time for consultation, you just have to act. In this case, consultation, and therefore the wise approach is what may make the difference. And now, for this topic, and I would say for analytical decision making, I am done. And we are, as I said, finishing the lectures on Friday, and my plan from now to Friday is, first of all, to provide you some examples where uncertainty is really relevant, and some example of decision-making processes applied to very important problems. And then on Thursday, I would like, during the 3 hours, if you bring the PC, I would like to make a final exercise on the use of utility theory to take into account within the design process our propensity or aversion to risk. And then on Friday, I would like to make a closing lecture on climate change, maybe that I introduced it already today, climate change and impact of climate change in water resources management. And at the end, I would like to reserve at least half an hour for question and answers, because I think it may be useful. Before I move forward, one thing, it is quite likely that I need to postpone to May 5th the exam that I promised to you, but only if there are many people that want to take it. How many of you? Would you please raise your hand? Because I got a subscription, so basically 1, 2, 3, 4, 5, 6, 7, 8, yeah, about 10. It's not possible for me on May 4th to make 10 exams, so I would propose to postpone on May 5th. Let me just check. And then if there is someone of you that is for whom it's not possible May 5th, I can make some exceptions for May 4th. Okay, this is what I would like to propose, because unfortunately there is a meeting that I have to attend. Do you have lectures on May 5th?
Yes, on the morning.
In the morning?
Yes.
But 10 exams, it's not a big problem. 10 exams means about 3 hours. We could start at 2:30 in the afternoon. 2:30 in the afternoon. It's about 3 hours. No, do we have lectures in the afternoon? Okay. Up to 4 o'clock. And therefore, while on May 4th you would be free.
I'm speaking about environmental engineering. Maybe we can be split into groups, civil and environmental.
Okay, so please, let's move forward in this way. You know that I can make about, let me say, I think 5 exams on May 4th is fine. And just 1 second.
On Wednesday we have free.
Sorry?
On Wednesday we have totally free the environmental.
Yeah, but Wednesday is not too late for you, no? Let me see. Who would like to stick on May 4th? Could you please raise your hands? Just 3 people. Okay, so I would say that May 4th for 3 people is fine. And who is willing to take the exam on May 5th? Okay, who cannot in both days? No, it's impossible because you said May 5th. You cannot in both days?
No, because I have an exam.
Sorry?
I have to do another exam so I can work.
Okay.
On 4th.
So even in both of them, 4th and 5th, so it would be a problem anyway for you, even if I kept the original date. That's correct?
I will try to do the 50th.
Yeah, otherwise for one person I would say you can send me an email and the 6th is fine for me, if it is one person, okay?
No, I would manage to do it in between.
In between. Okay, so let's say I received so far only 1 subscription, and who was the guy who subscribed yesterday? It was not you, correct, perfect. Not the guy, the girl. Sorry, I didn't look at the email, I just saw the subject and I didn't understand, I didn't look at the name, sorry for that. And you may take it on the 5th.
Yes, but it would be better in the morning, not
On the 5th, yeah, no problem for that. No problem. I have basically nothing all the way, all the day. So let's say that the 3-4 persons that would like to take the exam on the 4th, I can do that, but only in the afternoon after at 4:30 p.m. Is this fine for you? Okay, so please subscribe. Send me an email with the subscription. And for you, just if you want to change the date, you just have to send me another email. If you want to keep that, it's fine, and I keep them for the 4th. So what is your...
I will change them for 5.
Okay, so can you please send me another email? Okay, very good. And the same for all of you that want to take the exam on the 5th, please send me an email to subscribe, okay? Because I need to get a picture. Okay, that's fine. Perfect. So, let me move forward then, and let me give you some examples. And I want to talk, and this is also, I think it's very interesting, and on the other hand, relaxing. This is not the subject for any question at the exam. I want to introduce you to some very important water resources management problems. Important, I mean large scale. And keep in mind that the interest in a problem is not related to its scale. I had to deal with some very local problems in some cases, which I found very interesting. Of course, the appeal of a large-scale problem like this one is probably higher because you see many people involved. You see that societal conflicts may depend on the solution that you find for this problem. So the appeal is, of course, higher. It's more relevant, but let's distinguish the appeal, so the fashion, from the interest, because the interest to me is related to the fact that you really have to think hard to find a solution. And I think that even if it's a very local problem, like for instance the one that I introduced to you at the beginning of the course, just for a small region, I think that even if it's a local problem, it becomes interesting if you really have to think hard to find a solution. In this case, I think that the problem is indeed very appealing, and it's related to the management of the water resources conveyed by the Nile River. And this is an interesting, an appealing problem because at least the history is very long. You know that the Egyptians depended on the floods and the water for irrigation from the Nile River. But with the evolving societies along this very long river, the problem became more articulated. And the reason is that when you have a river that is shared by many countries, and we call them transnational rivers, the problem is that the actions taken by one state have an impact on the other states. And the different states have different laws, different needs, and therefore it's clear that the problem becomes more complicated. In particular, one should look carefully at the impact of the actions taken by upstream countries, the impact on downstream countries, because it's clear that if you withdraw water from the river upstream, you have an impact downstream. And at a first thinking, at a first evaluation, you may say that this is something that it's not convenient. You may say it's not convenient that people living upstream use the water without thinking at the downstream people. On the other hand, you should consider that the water that upstream countries may take, it's water that rained over their country. So it's difficult to say that they don't have the right to fully use such water resources. So let me make the example more specific of the Nile River. There are several states which insist over the Nile River, and the most important, meaning that the most important in terms of usage of water resources, are Ethiopia here, and Ethiopia is important because a very important branch, reach of the Nile River is the Blue Nile, and the Blue Nile origins from the Ethiopian mountains. And it goes, you see, it's not easy to see here, but this is the Blue Nile, which origins from Ethiopia, enters Sudan, and then after entering Sudan, joins the main Nile, and then the Nile flows downstream and reaches Egypt. So basically you see that the basin is something, the Nile origins from Lake Victoria, so all these countries are originating through their water resources. The Nile River flows, and Egypt is only the last downstream one, and it's also quite small in terms of geographical extension. But Egypt has a long history of usage of water resources from the Nile River, and therefore they built a lot of infrastructures because their livelihood completely depends on the Nile River. And in particular, they started first in building dams along the course of the Nile River. The famous Aswan Dam was built in 1900, so it's 115 years old. And it was replaced by an higher dam around, I think it was at the end of the 40s, around 1950. And basically the first dam at Aswan was replaced after about 50 years by an higher dam. But basically they started first in building dams, important dams on the course of the Nile River, and they built a dam because they wanted to store water in order to make the river flow along the Nile River more regular. Because if you build a dam or reservoir, you can store water when you have a lot of flow, and then you can release water downstream when during dry periods. Or you may use the water in the reservoir for irrigation. And also they use at the Aswan Dam, they use the water for hydropower generation. So it's a multiple-use reservoir. And afterwards, after building the dam at Aswan, the other states started claiming their part of water resources. And in particular, Ethiopia recently launched a new project and decided to build a very huge dam, which is called the Millennium Dam, and the position is about here, along the Blue Nile, about here. And it's close to the border, maybe a bit more downstream, about here. It's close to the border with Sudan. And the Ethiopians want to use this water not for irrigation, because it's very close to the border. They want to use the water for hydropower production. This is the main purpose of the Millennium Dam. And the Millennium Dam is a huge project, but you see that the system is indeed very complicated. You see how many reservoirs, these triangles are reservoirs. You see how many reservoirs are displaced along the Nile River. And there are many of them, and you still don't see the Millennium Dam. I think it's this one, the last one, close to the border. And there is another reservoir which is located in Sudan, which is immediately downstream. So basically, what's the moral of the story? The moral of the story is that both Sudan and Egypt are very concerned by this project of the Millennium Dam. And I think I have some details here. And I come back to these slides later. I just wanted to show you the Wikipedia page of this Millennium Dam. The official name is Grand Ethiopian Renaissance Dam, which is also called, it's written here, formerly known as the Millennium Dam. And you see a rendering, and a rendering because they just started filling the reservoir. They just finished to build the dam, and now they are filling, they are starting now to fill the reservoirs. Keep in mind that a very large reservoir like this one may take some years to get full, because you need to make a smooth storage, because otherwise you take all the water available. And in any case, even if one took all the water available, filling such a reservoir requires a lot of time. And the construction began in 2011. So as you see, it's a reservoir that is relatively recent. And it's recent, not relatively. I just would like to see if I have the connection. I want to show you the updated page. If one search for Millennium Dam, here you get. And it's already updated, of course. You see that there is also a map of the basin, and basically you see that the storage reservoir, this is what I was looking for. The storage reservoir has a surface area of 1,500 square kilometers. Just to give you an idea, 1,500 square kilometers is about the extension of a province in the Emilia-Romagna region. And the Emilia-Romagna region is 22,000 square kilometers, and it means that this reservoir is about 10% of the Emilia-Romagna region. It's very large. It's a huge lake. And there is a height of the dam which is about 150 meters, and the volume of water is equal to 79 billion cubic meters. So it's a huge amount. If you think the Bayonne Dam, which was built in Italy, it was 250 millions of cubic meters. So basically a quarter of a billion. So you understand the size of the lake that this dam originates. Is really something that is huge, that has an impact on the local climate, has, of course, any impact on the downstream water resources. Although they say that they don't use the water. So what is changed, what is impacted is just the natural river regime. So downstream, the Ethiopian claims that downstream they will get the same amount of water. It's just the timing of the river flows that changes. And indeed, if downstream you have other reservoirs, the fact that the timing is changed shouldn't affect much the dynamics of the releases from the reservoirs. Still, there are some concerns because you know, the fact that some water is stored in a reservoir means when the lake is so large, means that a consistent part of water resources goes out for evaporation. And this is a significant water loss, which you wouldn't have if the dam was not there. And basically, if you think the dam is 1,500 square kilometers, if you think at an evaporation of, let's say 1 meter per year, which is like an average at the global level, then it means that you get, let's see how many cubic meters of water are lost every year. So basically, if you have 1,500 square kilometers to get in meters, you have to add 60. And if you multiply times 1, it means that you get 1.5 billion of water of the result is every year you lose 1.5 billions cubic meters. It's 1.5 times 10 to the power of 6 cubic meters, which is, I mean, if you think that the Vayant Dam was 1/4 of, it means that every year you get 6 storages like the Vayant Dam that evaporate, and they wouldn't evaporate if the dam was not there, because of course the extension of the river is negligible if compared with the extension of a dam. And therefore this is a matter of concern, because downstream they say, okay, but we are going to lose anyway a significant amount of water, which of course, if it is compared with the annual volume of flow of the Nile River, is not so huge, but still, it's a significant amount of water that they would lose. And moreover, there are concerns because even if the Ethiopians declare that they are not using the water for irrigation, once that the water is stored, it's clear that in the future people may change their mind, they may decide that it's worth using part of the water for irrigating the field and etc. And there is to say that the Ethiopians rightly say that this is their water because it's water that originates from rain that fell over Ethiopia, and therefore they have the full right of using it. And you understand that the problem is not easy to solve. On one hand, one sees the point of downstream people, on the other hand, even upstream people have a good point. And so reaching a consensus is not easy. And basically what they did for this dam, they started an international consultation, and also they formed a body which is called NBI, Nile Basin Initiative, which it was established as a body including representatives from the governments, the relevant governments, and including a pool of international experts, not citizens of any of the involved countries. And the international experts were asked to provide an independent assessment and to act as mediators in this decision-making process. And of course, this led to signing a treaty. And in the treaty, these people agreed how the dam should be managed and how long should the dam take to get full, because also the transition which is needed to fill the reservoir was a matter of concern, and also the treaty it regulates how the water is used. And this is an interesting, I think it is a very interesting problem. I suggest you to have a look at the website and also the links. And it's also interesting, you are an engineer, we are not inspecting the problems related to the construction of the dam, how the dam is built, and what kind of structure the dam has. And keep in mind that it was an Italian engineering company who was called to design this dam. So if you follow the links, you may also find details on the design of the dam, which are, in my opinion, very interesting. I go back to the PowerPoint presentation, and here you see a zoom on the rendering. As I said, this is a dam that is about 150 meters high, even if there are some details. It's a gravity dam. It would be the largest hydroelectric power plant in Africa, with a capacity of 6,000 megawatt. The cost of the dam is about $5 billion US, and basically you see the height is about 150, 170, because you know that these data were provisional. When I completed this PowerPoint, the data were still provisional. And there is, as you see there, a treaty was signed by the Upper Riparian State, and it was not the first treaty. They also signed a treaty about around the 60s of the past century, because of course this is sharing the Nile of the water of the Nile River has always been a very relevant problem. I go back with my slides to the description of the problem, and then there is a technical issue related to the hydrological design of the dam that I would like to introduce to you in detail, because I think it is an example of an interesting problem related to the design. But first I go back to my slides,